Lesson 15.2, Task 1. Define and evaluate the basic trigonometric functions. All right, we're going to use special right triangles in the unit circle. So when studying right triangle trigonometry and geometry, the functions sine, cosine, and tangents each represented a ratio of side lengths of a right triangle. All right, so remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Some of you guys may have learned it as SOHCAHTOA. So SOHCAHTOA is just an easy acronym to remember: sine, cosine, and tangent. So you've got the sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so you also studied a relationship between the side lengths of a special right triangle. So we looked at 45, 45, 90 and 30, 60, 90 triangles. All right, so if I can scroll down here a little bit. All right, so you can see that 45, 45 have two equal angles and two equal side lengths. So you got side, side, and side times square root of 2. So your hypotenuse is always opposite your 90. So your hypotenuse is side length times the square root of 2. For a 30, 60, 90, your short side is across from 30. That's your side length. Your longer side is across from 60, and it's side times square root of 3. And your hypotenuse is across from your 90 again, and it's twice your side length. All right, so once you have these triangles, or when you have these triangles and it has a hypotenuse that is 1 unit, you can inscribe the triangle in a unit circle. You can use these triangles to find the value of the trig functions for a 30, 45, and 60 triangle. So let's look at that. So it says the special triangles shown in each inscribed in a unit circle. A 30, 60, 90 triangle is shown in 2 different orientations. For each triangle, the coordinates of the points where the hypotenuse intersect the unit circle are given. All right, so you can see here, the radius is 1. So it means the hypotenuse of this triangle that they've drawn inside here is a 45, 45, 90 triangle with a hypotenuse equal to 1. So where these side lengths came from just comes from the 45, 45, 90 triangle. So we know that we have the hypotenuse is equal to 1, and your hypotenuse is equal to a square root of 2. So if your hypotenuse is given, you can find a by simply solving for your variables. So we have 1 over square root of 2 equals a. We have to rationalize our denominator. So we're going to get square root of 2 over 2. So that means both side lengths of your 45, 45, 90 triangle with a hypotenuse of 1 is going to be square root of 2 over 2. So you can see that is given here in this first unit circle. All right, same thing with the next one. If we have a 30, 60, 90 triangle, so you have a 30, 60, 90 triangle. If we already know that the radius is 1, which means our triangle is going to have a hypotenuse of 1, we can say 1 equals 2a. Solve for a equals 1/2. All right, so that's our short side here. A would equal 1/2, and then the other side would be 1/2 times the square root of 3, which is just the square root of 3 over 2, because that would be over 1. So this side would equal square root of 3 over 2. Now you can see that this is your x and this is your y value. So that's why it says square root of 3 over 2 and 1/2. Now if you switch these and make this 60 and this 30, then your short side and long side switch. So you can see how in the last triangle here for the unit circle, it's just the opposite of the 30, 60, 90. It's the 60, 30, 90 triangle. So that's where these numbers come from, is just looking at these special right triangles. And again, these are very important. If you take the ACT, you more than likely will see those at least once or more on the ACT. All right, so in each of the triangles, how does the hypotenuse of the triangle relate to the radius of the circle? The length of the hypotenuse is equal to the radius. That is true. Half, no. Square root, no. Okay, so the first answer is the only correct answer. All right, how can you use the relationship between the sides of the 45, 45, 90 or the 30, 60, 90 to determine the coordinates of the point where the hypotenuse of each triangle intersects the unit circle as previously shown? Select all that apply. All right, so the first one says for a 30, 60, 90 triangle with its short leg along the x-axis and the y-coordinate are the reverse of those for the 30, 60, 90 with the longer leg. Yes, okay, so that's what we just said a second ago. So if you look at the two here, these are just reversing your x and y coordinate. Okay, so that's what that's saying. That is true. For a 30, 60, 90 triangle, the leg length of 1 and square root of 3, that is not true. So remember they were 1/2 and square root of 3 over 2. All right, for a 45, 45, 90, the x and y are the same, and there's a square root of 2 over 2. That is true. If you remember, we found that square root of 2 over 2 is the two leg lengths for your 45, 45, 90. For both types of special triangles, the horizontal leg extends from one end of the hypotenuse along the x-axis to a point directly below the intersection. So the intersection point has the same x-coordinate as the length of the leg. The vertical leg connects the x-axis to the intersection point. All right, so that's very long and confusing, but that's basically saying this point to the intersection point of this point here. So this makes your x and this makes your y. So this intersection point along the circle drops straight down to make your triangle there. So that one is true as well. All right, moving on to the table. It says use the triangles to find the values of the trig functions for the angle of rotation. All right, so remember we've got SOHCAHTOA. So we know that we've got sine is going to equal opposite over hypotenuse. And so if we refer to our triangles, hopefully you have those written down. I don't want to have to scroll up each time to look at those. So we know that sine is going to be opposite over hypotenuse. So if we look at our 30-degree triangle, we're going to have opposite of 1/2 over 1. 1/2 over 1 is just 1/2. Our 45 degrees, opposite over hypotenuse, is going to be square root of 2 over 2 divided by 1. Anything divided by 1 is just that number. And our 60-degree triangle, the opposite over hypotenuse is going to be square root of 3 over 2. Yeah, square root of 3 over 2 divided by 1, which is just square root of 3 over 2. All right, cosine is adjacent over hypotenuse. So if we look at our 30-degree angle, our adjacent is square root of 3 over 2, and our hypotenuse is 1. So square root of 3 over 2. All right, our 45-degree angle is going to be square root of 2 over 2 over 1. And then we have our 60-degree angle. So our 60-degree angle, we need adjacent over hypotenuse. So we're going to have 1/2 over 1, which is just 1/2. Okay. And then our tangent is opposite over adjacent. So our tangent, opposite over adjacent. So I'm looking at my 30-degree angle. Opposite is 1/2 over adjacent is square root of 3 over 2. All right, so dividing a fraction by a fraction means I can multiply by the reciprocal. So that means the 2's cancel, and I have 1 over square root of 3. Rationalize the denominator, I get square root of 3 over 3. Alright, so my tangent's going to be square root of 3 over 3. For 45, I've got square root of 2 over 2 over square root of 2 over 2. Anything divided by itself equals 1. Alright, 60 degrees. My opposite over adjacent, I'm going to have square root of 3 over 2 divided by 1/2, which is multiplied by 2, which 2's cancel, and I get square root of 3. Alright, if you need to write each one out and work it out, you can do that. But to save a little time, I'm going to move on. Alright, so those are your trig values. And then how do the values of the trig functions relate to the coordinates of the points of the intersection on the hypotenuse of the unit circle? So the value of blank functions are equal to the x-coordinate. Alright, so if you look up here above, so we've got 1/2 and square root of 3 over 2. So let's look at our 30-degree triangle. So square root of 3 over 2 and 1/2. So that means we've got our cosine and then our sine. So our cosine is our x value, and our sine is our y value. Alright, so you define each coordinate on the unit circle in terms of the trig function of rotation. X is our cosine, y is our sine. Alright, that's all for task 1. If you have any questions, let me know.